Hi guys, in the previous video I introduced you to differentiation and we just thought about how we do it with a basic polynomial. In this video we're going to start to think a little bit about what differentiation actually means, right? What does it tell us that is useful and important? So we'll do that first by looking at a very simple function, y equals x squared. Now I've got a graph of it here on the left hand side that isn't quite to scale. But let's think about that. If we differentiate y equals x squared, what should we get? Well, as you remember from last week's video, you bring the power 2 down to the front and you reduce that power by 1. Right? So dy dx here is going to equal 2x. But what does that 2x mean? What does it tell us? Well, it will tell us the gradient of the function y equals x squared at every value of x, right? It tells us the gradient of this function here. So let's have a quick think about that, right? Let's think about when x is equal to 0, right? So when x is equal to 0, what is dy dx equal to? Well, dy dx will be equal to 2 times by 0, which is 0, right? And that's what we see when x is 0, which is here. The gradient, if I can draw it, is 0. It's a perfectly flat line. Okay? Well, let's think about another value of x. Let's think about the value x is equal to 1. Right? When x is equal to 1, what's dy dx going to be equal to? Well, it's going to be equal to 2 times by 1, which is just 2. So let's have a look at that. When x is equal to 1, this is our point on the graph y equals x squared. And the gradient there, we're being told, is going to be what? Is going to be 2, right? It's going to go up by 2 for every one step across. Let's think about another one. Let's say that what we have is the value x is equal to 2, right? So when x is equal to 2, what's dy dx going to be? Well, dy dx is going to be 2 times by 2, which is equal to 4. So the gradient here, when x is equal to 2, is going to be 4. And you should notice that that kind of makes sense, right? Because the gradient when x is equal to 2 should be steeper than the gradient when x was equal to 1. So in other words, as the values of x increase, our gradient of our quadratic is going to get steeper and steeper. And that's true. That is what we see. Well, let's just consider one other point. Let's think about a negative point. Let's think about x is equal to negative 2, shall we? X is equal to negative 2. Well, then dy dx is going to equal to 2 times by minus 2, which is negative 4. So if we take the value x is equal to negative 2 over here, right, what's our gradient going to be? Our gradient, you can see it's going down. Sorry about that, bad line. The gradient's going down. And it's going down at a value of negative 4. So in fact, it's the opposite gradient to what we just had over here. And hopefully you should also be able to see that for every value of x which is negative, right, for all of these x values over here, right, then the gradient is also going to be negative because the graph is sloping down. So if x is negative, then dy dx will be negative, which means the gradient is always sloping down. And if x is also positive, right, on this side of the graph, then dy dx will also be positive, which means the graph is always sloping up. It's always got a positive gradient. So to recap, what is the big point? What's the key thing that you need to know? Is that differentiation tells you the gradient for every value of x, right? That's the key point there. Differentiation tells you the gradient for every value of x. So now, from this point onwards, every time you think about differentiation, you need to have in your mind gradient. What is differentiation? It is the gradient. So let's have a look at a more complicated example here, right? So here we've got this big function there. And in the last video, we learned how to differentiate something like this, right? Remember, all it is just the sum of all of these different polynomials, right? We've got 2x cubed and minus 5x squared and 2x and 4. So we just differentiate each one of those individually. So if I differentiate 2x cubed, again, I bring the 3 to the front. So I'm going to get 3 times 2, which is 6. And I reduce the power by 1. For this one, negative 5x squared, I bring the power of 2 down. So that's going to give me 10x, because I reduce the power of 2 to 1. When I have 2x, if I differentiate that, that's just going to give me 2. And remember, if I differentiate any constant value, like 4 here, that gives me 0. So in the end, what do I get? My differentiation, my dy dx for this function is 6x squared minus 10x plus 2. 6x squared minus 10x plus 2. So now what we're going to do is we're going to ask the question, well, what is the gradient of this function here, right, for particular values of x, right? What is the gradient, that function there, for particular values of x? Well, let's just try one, right? If x is equal to 0, what's the gradient going to be? Well, I just substitute 0 into my dy dx. So I will get 6 times 0 squared minus 10 times by 0 plus 2, right? So I just take my x value, x is equal to 0, and I shove it into my dy dx, right, into those points there, right? That's what I'm doing. So what will I get? Well, I think you should see it's fairly obvious in this case, right? 0 plus 0 plus 2. So dy dx is 2. So what does that mean? It means that when x is equal to 0, on the graph of y equals 2x cubed minus 5x squared plus 2x plus 4, it means that the gradient at that particular point is 2. The gradient there, the gradient at that point is equal to 2. Okay? Let's try another value. Let's try the value when x is equal to 1. So when x is equal to 1, what do we have? Well, let's again substitute x into our dy dx. So dy dx is going to be 6 times by 1 squared minus 10 times by 1 plus 2. And 6 times by 1 squared is 6 minus 10 plus 2. Right, so what's that going to be? That's going to be minus 2. Okay, so when x is equal to 1, dy dx is negative 2. That means that when the graph has got a value of x is equal to negative 1, the gradient is going to be negative 1. And you can kind of see that there, right? The gradient of that line there is negative 1. It is definitely sloping downwards. That's why we get a negative, right? And so the value of the gradient here, if you were to calculate it, if you were to kind of draw your triangle out and try to calculate it, you would get that is negative 2. Okay? Now then, let's do one last value. All right, let's do x is equal to 2. So when x is equal to 2, let's again substitute our value in. Dy dx is equal to 6 times by 2 squared minus 10 times by 2 plus 2. So that's 6 times by 4, which is 24, minus 20 plus 2. So that's going to be a gradient of 6. Okay, so what does that tell us? It tells us that when x is equal to 2, on my graph there, the gradient is going to be equal to 6. Right? So the gradient at that particular point, the gradient is equal to 6. Okay? So if you take all of those things together, right, what have we seen? Well, we've seen that if we take the gradient here when x is equal to 0, and we've got a particular value there. When the gradient's here, when x is 1, we've got another value there. Right? We've got different values for the gradient for all these different points of x, right? Because the graph itself, the blue line, is curving up and down and up. Okay? And so the gradient is always changing. So when you put in a different value of x, you'll always get, or you should get for most of these functions, different values, and those values represent the gradients at their respective points. Okay? I've just got one last thing that I think I want to challenge you with. So if you're want to think about this a bit more, you notice that when x was 1, the value has changed to a negative. And that sort of makes sense, right? Because if you think about it, between here this point here, and this point here, the graph is always sloping downwards. So here, dy dx must be negative, right? Because the gradient is negative. And similarly, for these values here, where the graph is always sloping up, like that, right? If the graph is always sloping up, then dy dx there must be positive. Yeah, for those green bits, the dy dx is positive. So if you want to have an extra bit of challenge, what I want you to do is I want you to try to think about how you could find these points, right there, those points there, where the gradient changes from being positive to negative and back to positive. If you want an extra challenge, see if you can figure out those 2 points. Okay, so to conclude, we want to think about what does differentiation actually mean? What it means is that it tells you the gradient for every value of x. What is differentiation? Differentiation tells you the gradient for every value of x. Okay, guys, so if you're in my class and you want a bit of practice on that, I suggest you look at exercise 12.1. I think you should now have just about enough to complete that exercise. Okay, take care, guys. I will see you next time.